Hello ROS developers and welcome to a new open class number 152. Welcome everybody, and today we are going to be talking about C++. So we are going to be moving away just a little bit from ROS, but still keeping an eye on it. But the focus of today is to get introduced to C++ and more specifically to using C++ classes. But as always we do in the construct, we are going to apply this concept of C++ classes and object-oriented programming to ROS. So we are going to see, try to understand and make a simple example of how to combine these two. What is the structure that you have to do when creating a class for ROS. This is the objective of today's open class. So let's get started. Welcome everybody again. Let me know, as always, here in the chat, please, if the sound is fine, if the image is fine. So I'm going to move right now to my computer screen so that I can start seeing your messages and everything. Let me move here directly. There we go. Okay, so let me come here. Well, actually, let me come through this button, which is the fastest way. All right, so here I have the live stream, which seems to be okay. Hello, Darius. Hello, Engracia. So, yeah, I suppose everything is fine. So, so let me know. Let me know, all right, in the chat if something is wrong. Just let me know. Then so we are going to get started. And as always, the first thing that we have to do in order to be able to do this open class is to get the rosject. Yeah. Then in order to do this, all you have to do, very simple, is to click on this light blue button that you have right here above the chat. So I'm going to click myself here. And basically, this is going to create a copy of the class rosject into your account, into your workspace, and it's going to also automatically open it and bring you here to the rosject screen. So you are going to have here at the right side still all the streaming area with the live image, also the chat, so that you can write here. Let me see. Hello. Say hello to Juan David, Laura. Okay, so I see that Juan David it's a little bit confused about his emotions. I don't know if you are sad or you are happy. You have to choose one, Juan. All right, so yeah, after some seconds, the rosject is going to get loaded here, and yeah, let me just remind you that you are going to have a copy of this rosject forever in your account. Yeah, once you get the copy, you are going to have it there in your account forever, so you can open it whenever you want. You can review it next week, next month, whenever you want. Okay. Then yeah, so please, all of you, click on this button in order to get the rosject, and then let's just wait here a few seconds. It shouldn't take more than 1 minute, so that the rosject gets completely loaded. Then once this happens, you are going to have also the notebook automatically opened here. And yeah, so you have to make sure that you are in the proper one, which you should be, which is the one for class number 152. All right? I see now, by the way, that the image is wrong, so don't pay attention to this image, okay? This image is wrong, but the title here is correct. Yeah, so it's open class number 152. Yeah, so are you here? Let me know, please. Any issues? Have you been able to get a copy of the rosject and open it? Yes, no? Let me know here in the chat, please. Robin says that it works. Ben Catraman also confirms. Okay. Perfect. then we are ready to get started, right? So the first thing that we are going to do then is to launch a simulation. Yeah, so we are going to start by launching a ROS simulation. We are not going to use it at the beginning, but we are going to use it and interact with it at the end. So let's just launch it right now, and we are going to leave it there in the background until we use it at the end of the class, okay? Then, yeah, so the first thing you need to do now is to open a new shell, all right? Then in order to open a shell, you have to click on this button, like it is indicated here in this image. It's the first button that you have here in the bottom bar menu, here. First one, which says web shell. Then just by clicking here in the first button, this is going to open, as you can see, for me, a new shell. This is a regular Linux Unix shell where you can type regular commands, okay? So yeah, first thing is to open a shell. Then next step is to launch the simulation. And we are going to do this by executing this command that we have here, this ROS launch command. So you can directly copy it here from the notebook. In fact, I recommend you to do it like this because it's going to save you time, so you don't have to type all the commands and everything. So let's just select this command here from the notebook. You can copy it, and then in the shell, we are going to paste it, okay? And then just execute it. This is going to start running and starting some processes related to Gazebo. And after some seconds, the Gazebo window, as you can see, is going to automatically pop up here. And now in this Gazebo window, we are going to be able to visualize the simulation. Here you go. Yeah? So after some seconds, you should end up with this Gazebo simulation here. Yeah, you have here this wall right here, and two turtlebots here in the center of the simulation. Juan is asking, are we going to work with ROS? Yes, we are. We are going to be working with ROS. In fact, this is already ROS. Okay, so this is a Gazebo with ROS simulation. Oh, I suppose that you say ROS1. Yes, we are going to be working with ROS1. Juan. Yeah, we are going to be working with ROS1. Okay, yeah, so once we have the simulation, you can minimize it for now, okay? We are going to come back here at the end of the class, because we will be interacting with this. But for now, you can just minimize it, yes, and here, just leave the processes running, okay? Because if you close this, the simulation is going to be also terminated. So we are going to just leave the simulation running in the background. Then before starting, okay, just as a requirement for this class, I have added here a link to our basic C++ for robotics course, which is free, by the way, so you can do it completely free. And in this course, you're going to get a very basic introduction to some C++ concepts, like conditional statements and loops, function creations, basic usage of arrays and pointers, also an introduction to classes, yeah. So it is a very interesting course. In case that you don't know anything or you know very little about C++, it's a very good starting point, okay? Because you are going to learn basic stuff, basic C++ stuff that you are going to need if you want to become a robotics developer, yeah? And it's completely free, okay? So you can do it completely free. Then, for this class, we are going to focus on C++ classes, okay? So because of time limitations, we are not going to be able to get too deep into this, but we are going to see some basic ideas, and we are going to see, which is the most interesting part at the end of the class, how to create a C++ class for ROS, okay? Then, First of all, C++ classes are part of what is known in programming as object-oriented programming. Yeah. So object-oriented programming it's a let's say it's a technique of writing code which is widely used around the world, and it's the recommended way of creating your codes because it has many benefits. Between them is that you are going to provide programs with a modular structure. For instance, they are going to be much more easier to maintain and even to modify by yourself or by third-party developers, which are not directly related to the code. But basically, so your code is going to be much more well organized, and it's going to be much more easy to reuse it. Yeah, so reusability is a key word here in object-oriented programming. Then if you want to write your code in an object-oriented way, you have to use classes. Okay? Then classes are the main way of structuring your code in object-oriented programming. Yeah. So here we have an example of with ice trays and ice chunks, where the ice trays would be the classes and the ice chunks would be the objects. So let's say that the class is a template for creating an object. Yeah? So a class provides you a template for creating objects. And then the objects are the ones that you are going to be using. For instance, you can create a template of a class for defining this ice tray, or for defining all the ice trays. And then you can create objects depending on the attributes of each specific ice tray. Yeah? So objects are derived from classes. Then this might sound a little bit abstract, okay? But let's get into practice and try to see these try to see all these concepts into a code. Yeah, because I think this is going to make it easier for us to understand instead of just talking and explaining here abstract concepts. Yeah. For now, just keep in mind these keywords, which are object-oriented programming, which is a way of writing your code so that it's more organized and it's more reusable. Okay. Second, you have the class keyword. The class is a template for creating objects. All right? Then, let's create our first example of C++ class. For now, we are going to keep ROS outside, okay? So this is pure C++. So let's start. Then we are going to create a new folder, which we are going to name demos, inside our Catkin workspace SRC. Yeah. So for this, I would recommend you to open the code editor because it's going to allow us to interact with files and folders using a graphical interface, which is always much more user-friendly. So for this, all you have to do is to click here in this second icon, which says code editor, also in the bottom bar here. Yeah. So if you click here in the code editor, you are going to get this window appear. There we go. Okay, so this gives you access in a graphical way to all the workspaces that you have in this rosject. Okay, so in this case, we are going to only open the Catkin workspace, which is the one we are interested in. Yeah, because here in the demo, it's asking us to create inside Catkin workspace SRC. Yeah, so here inside Catkin workspace SRC folder, here inside, create a new folder named demos. So here I'm going to right-click in the SRC folder and select to create a new folder. And I'm going to name this new folder as demos. Okay? And now, inside the demos folder, we are going to create a CPP script, C++ script, named like this, demo1.cpp. Okay? So now I'm going to again right click here in the demos folder, and in this case I'm going to select new file, and I'm going to create a new file which I'm going to name demo1.cpp. Okay? There we go. So this creates a CPP file inside the demos folder, which at this point is empty. Okay? So now, final step is to put some code into my C++ program, right? So in this case, we are going to put the code that you have right here in the notebook. So how you can do this in a very easy way, very easy and fast way, just select the code here directly from the notebook. Select the code that you have here in this cell. Sorry. Let me select it again. Select it, copy it, and paste it. Yeah? Are you done? Have you created the folder, the script, and you have pasted the code into the script? Yes, says Laura. Perfect. All right. So let's have a quick look now at this code. Okay. So so we have an include here. We are including the IO stream library. Okay. This IO stream library is going to allow us to use certain functions like cout, cin, etc. Okay. We are using the namespace std, and then here I am defining a new class. Yeah, and this new class is going to be named like this: ice tray. Okay. So everything that I have between this opening bracket here and this closing bracket here is going to define my class. All right? Yeah? So I define my class. Then inside the class, I have a public keyword, first of all, which it's an access specifier. We are going to see in a moment. We are going to see a little bit more about this in a moment. Then we have the data members. The data members are just variables associated to our class. Okay? So our class has two data members or attributes, which are fish shape and star shape in this case. Okay? And then I am defining a member function. A member function is a function which is associated to the class. Okay? It is also known as a method. Some places you're going to see it called in some way or another. Okay? But basically it's a function which is associated to this icetrace class. Okay? So if I want to call this function, I'm going to have to call it through an object of my class. Okay? So very simple. I define my class, which has some data members and member functions. Yeah, in this case, it has two data members and one member function. The member function is just going to print here a message. Okay? All right. So here I have defined my class. Okay? But this is just a template. Okay? With this, I am really doing nothing. So if I want to actually use my class, what I have to do is to create an object of my class. Yeah? Then for this, I have here a main function, the main function of my code. Okay? Then in the main function, the first thing I do here is to declare an object of the iceTray class. Okay? This object is orange juice. Yeah, so orange juice is an object of the iTree class. Therefore, this orange juice object, it's going to have the fish shape and star shape attributes, right? Because orange juice is an object of the iTree class, and the iTree class has two attributes or data members, fish shape and star shape, right? Then, what I am doing here is to modify the fish shape and star shape data members from the orange juice object. Well, not modifying, but just giving them a value. Yeah, so for the fish shape, I am giving a value of frozen, and for the star shape, a value of not frozen. Yeah? And then finally, I am accessing a member function. Yeah, so I am accessing this member function, frozen status. And as you can see, I have to call it through the object, through the orange juice object. Yeah, and finally I exit returning a 0. Okay? Does it make sense so far? Yes, no? Do you see the structure, the general idea? Makes sense, says Robin Truth. Okay, perfect. Yeah, so classes are a very huge topic, subject. It has many details. It's impossible to explain all this in 1 hour, but at least so that you get the general idea. Okay? Then, all right, so now that we have a general idea of our code, we are going to compile it and run it, okay? So we are going to combine it here with clang++, which is a C++ compiler. Then, yeah, so let's come now to the shell, and we are going to open a new one, okay? This is very simple. You just have to create in this plus icon that you have here, and this is going to open a new shell here, all right? So now we can go using the cd command to catkin workspace src demos, okay? Here, where you have the demo1 cpp script. Yeah, and then here, we are going to run this command. This is wrong, by the way. The X, you can remove it, yeah? So the actual command is this one, yeah? clang++, then you specify the name of the script, which is demo1 cpp, then you have a -o, which stands for output, because we are going to generate an executable, which we are going to name demo1, okay? So if you run this, you are going to see that an executable, if I run ls again to see the contents of the demos folder, you are going to see that you have this demo1 executable here. Yeah? And then this demo1 executable, you can directly execute it like this. Okay, you have also the command here. And then this is going to execute the executable, which basically contains this compiled code. Yeah? And as you can see, the output is this crystal, which is in fish shape, is frozen, and the one in star shape is not frozen. So what we are getting as output basically is this. Yeah? Is this cout, the contents of the frozen status member function. Why? Well, because I am calling this member function here at the end of my code. Yeah? And fish shape, the first one is going to be frozen, and star shape, the second one is going to be not frozen. Yeah? So that's why I get here fish shape is frozen and star shape is not frozen. Okay? Yes? Have you been able to run the code? Okay? Bear in mind, yeah, so in the command here, in the first command, there is an X somewhere here, so remove it, okay? It's only, the correct command, it's like this. -O, without any X around there. What command did you run, Jayanta? What does Selang++ do exactly? It's building, it's compiling this code. Okay, Robin. So basically, it's just there are several things there behind the scenes of a build process, but basically it's compiling all this code and it's generating this executable file. Okay. Because you cannot directly execute this. You need to generate a compiled version that you can run in the computer. Okay, so the command is, let me paste it here. The command is this one for Jayanta. Just let me put it here so that you can see it. Okay, and then important things. First of all, you need to run this command here, inside the demos folder, okay? In the folder where you have the demo1 CPP script, okay? And of course, you need to have the demo1 CPP script with the codes here, okay? Damn it, here another letter got copied. This one it is. Okay, so you need to create the demos folder, and inside the demos folder you need to create this demo1 CPP script, and inside it you need to paste the code, copy and paste the code that you have here in the notebook. And then when you have this, you can compile. No, so if you follow the steps like this, it has to work. So review these steps, because probably you are missing something of this, or maybe you have the CPP script in the wrong place, or maybe you have copied wrong the code from here. You are missing some lines. Something, any of these could be. So review the steps, okay? Or now we are going to create another script. So you can try this second one, and then later you can review all the steps. But if you follow the steps one by one, it has to compile. All right, so let's have a quick look here at what this access specifier is. So in this code, we saw that we had this public keyword here, which is the access specifier, right? So what is this? What can this public mean? Okay. Does somebody know already? Yes, no? So basically, these access specifiers, what is known as access specifiers of a class, are used to control who can access and from where your class. Okay, so it's kind of a security measure. Okay, so with this you can control who and how can somebody access your class. Okay, then there are three access specifiers: public, private, and protected. So in this first example, we were using public. Public basically means that everybody can access and use my class, okay? So it's open to everybody, it's public. Then, by default, if you don't specify anything, the access specifiers are going to be private, okay? Private mean that members cannot be accessed or viewed from outside the class. So they can only be accessed and viewed from inside the class. Inside the class means here, means inside the opening and closing bracket. Yeah, this is inside the class. All right? So, and then finally we have the protected one, which it's that members cannot be accessed from outside the class, but they can be accessed through inherited classes, okay? Inheritance is another concept directly related to object-oriented programming, but we are not going to go over it on this class. You have a link here in case you want to learn more, and yeah, in this same course, there is a unit about inheritance, okay? So, let's have a look at this demo 2. So, if we have a quick look here at the demo 2 code, basically everything is the same. Yeah, we have the data members, member function, the main, we create an object, we give values, and then we call the method, right? So, here, what would happen if I change? Yeah, so in this case, I'm not going to create a new. I am not going to create a new code, demo 2, okay? So what we are going to do is to directly modify it here in the demo 1 CPP. So what would happen if I change this from public to private? What do you think is going to happen if I do this? Juan David is asking, why we use underscore before names variable? What do you mean? Are you talking about a specific line or? Ah, yeah, that's a way of programming. So that depends on the programmer. Okay, some programmers are going to use underscores before the variable name. In some other codes, you might not find that. That basically depends on the programmers. But basically, underscore before the variable name usually means that is a data member. It's an attribute of the class. Okay, that's usually the meaning. Okay, so I have changed it here from public to private, right? So what if I try now to compile my code again? Let's try. I'm going to try to recompile my code, and let's see what happens. Okay, so I am getting an error now, right? What is the error saying? It says, okay, here in demo 1 CPP line 27, there is an error. Fish shape is a private member of ice tray. Okay. Error in line 28. Star shape is a private member of ice tray. Yeah, so in lines 27 and 28, it's complaining about these two lines. In fact, in the code editor, as you can see, this is also marked in red. And if you put the mouse over this error, you are going to see also the same. Yeah, fish shape is a private member of ice tray, and the same for star shape. And then we have also this third error, which says frozen status is a private member of ice tray. Yeah, you can see it also here. So basically, it's complaining that these members are private members. So what does this mean? This means that I cannot access them from outside the class. And here I am trying to access them from outside the class, right? Because the class is this. Yeah? So if I try to access them here, I am trying to access them from outside the class. And I have just said that private members cannot be accessed from outside the class. Right? Does it make sense? So if I want to access class members from outside the class, I need to make them public, not private. Okay? If I make this public again, then this is going to compile properly. Right? Yeah? Does it make sense? So you can't. If you want to use members, so if you want to use members which are defined as private in a class from outside the class, you can't. You cannot do that. So if you want to be using or modifying members of a class from outside the class, yes or yes, you need to make them public or use inheritance. Okay? But making it simple, if you want to use call methods or modify attributes of a class from outside the class, you have to make them public. Yes or yes? And when we use private data member, do we use? I understand. Yeah. Yeah, I don't quite get your question here, Juan David. But yeah, let's see. Let's keep moving, and in order to get to see more examples. So, for instance, here we have. Yeah. So before we get to the final example, yeah, we have a couple of sections. So let's try to have a quick look at this. First of all, constructors and deconstructors. Okay. So classes have constructors and deconstructors. The constructors are in charge of initializing the class. Yeah. So whenever a class is created, whenever an object of the class is created, like it's being done here, the constructor of the class is called. Yeah. Then usually this constructor is used to initialize variables and this kind of stuff. Yeah, to initialize things related to your class. Yeah, and the constructor also in the constructor you allocate the memory location for an object. Okay, this is important. It's more advanced, but it's important. And in the deconstructor, you free the memory that was being used by the object. Okay. Then, as constructors, we have different type of constructors. For now, we are going to have a quick look at the default constructor and the parameterized constructor. So let's generate this code and see this example, which is pretty simple, and I think it's going to make it very clear. So inside our demos folder, let's create a demo3 CPP file. And now here, we are going to copy and paste this code here. Okay? Copy and paste it. All right? In demo3 CPP. Then we can have a very quick look here at the code again. So we are defining, again, our class iStray. We have a couple of data members, grab shape and tree shape. And then here we have our default constructor. Yeah? As you can see, inside our constructor, what we are doing is to initialize the data members. So we are initializing grab shape to frozen and tree shape to not frozen. Yeah, here I have a parameterized constructor. Yeah, so this parameterized constructor, as you can see, it requires a specific parameter for initialization. In this case, it requires a string. And then it's going to initialize grab shape to whatever it receives in this string, in this parameter. All right? And finally, here you have an example of the destructor. In this case, the destructor, it's just printing a message. All right? So in our main, we create an object of the iStrace class, and in this case, it's going to call the default constructor. Okay? So in this case, the default constructor is going to be executed. Now, down here, I am creating another object, a second object of the iStrace class. Yeah? So you can create as many objects as you want from a class. So here I am creating a first object, which is using the default constructor, and here I am creating a second object, which is using the parameterized constructor. And as you can see in this second one, I am sending a string. Yeah? So, in my first object, the grab shape is going to be frozen and the tree shape is going to be not frozen. And in my second object, the grab shape is going to be not frozen. Yeah? So, I have two objects from the same class which have different values in their attributes. Okay? And then finally here I am just printing the values of grab shape. Yeah? So in the first object, my grab shape, the data member, should be frozen. And for my second object, lemon juice, the grab shape data member should be not frozen. All right? So when I execute my code, I should get this. Frozen and not frozen. So let's again compile here. Let's compile our demo3 CPP and generate the executable. There we go. And now we can run it with demo3. Yeah? And then here we have frozen, not frozen, and then the destructor is called 2 times, right? The destructor is called for 2 times for the 2 objects, for the orange juice and for the lemon juice. Okay? Yeah, so private data, if you define a data member as private, it's because you don't want people to modify it, basically. Yeah, so it's a way of protecting the data members of your class. Yeah? If you create a class and you don't want people using your code to be able to modify some data members, then you are going to define them as private, right? Yeah, so does this make sense? This example, yeah? Pretty simple. Yeah, does it make sense? Okay. And then, yeah, so we have here structures also, which I think I'm going to skip it and move directly to the last example. Okay? Because I think it's going to be more interesting. So structures, let's say, that are a way of defining, of grouping a set of characteristics into a single structure, okay? But I think I'm going to skip this. You can check it later if you want. Robin is getting this error, so if you are getting this error, it's because you don't have this file. As it says, no such file or directory. So you don't have this file, Robin, this demo3 CPP, you don't have it, or you are running the command from another folder. You are running the command from a folder where you don't have this file. Either one of two. Yeah? Okay. Then let me move directly to this last exercise because I think it's the most interesting one. And I'm going to skip this structures part. So as for the exercise, okay, we are going to first define the exercise, and then later we are going to solve it, okay? So the exercise is divided into parts. First, we have to create a package, a ROS package, named My Robot Manager, okay, with certain dependencies. Then we are going to create a header file named robotmanager.h. And we are going to create a source file named robotmanager.cpp. Okay? This is very typical in, or this is the recommended way of implementing a class when working with ROS. Yeah, so you are going to divide it into, generally it's going to be divided into 3 files. Yeah, the header file, which contains the class definition, the source file, which contains the class implementation, yeah, and finally, you are going to usually have a main file, let's say, which is the one that uses your class. Yeah? We are going to see this in a moment, okay? Then our class is going to keep the data of the following pieces of information: the current X position of a robot, the current Y position, and the odometry topic. Yeah? So it's our class is going to subscribe to this topic, robot1 odom, which is the odometry data of a topic, in order to get the current X and current Y values of our robot. All right? So we are going to have to create a subscriber for the odometry topic. Yeah, you have the structure here. And yeah, and we are going to have to compile the source file into a library. Okay? Very important. So we are going to create the header file of the class and the source file. And then we are going to generate a library from our class. And then I'm going to use my class as a library from a main code. Okay? This is the general structure. Then in the main code, let's say, you import the Robot Manager library. You create the main function. You initialize the ROS node by creating a node handle. Yeah, you create an object of your class, and we spin the code. Okay, then this is the definition, but let's do it. Let's solve it, okay? So at the end, we should get something like this. We should get as output the values of the position of our robot in the XY coordinates. Then let's start by solving this step by step, okay? So that it is clear for all of us. Then let's start. So we are going to come here to the, let me make this, let me put this here in the side. Okay. Then let's go to King workspace SRC, okay? Very important, first step. CD King workspace SRC. So we need to be in the SRC folder of the King workspace. Why? Well, because this is the folder where you have to create ROS packages, right? Then once you are in this folder, you can run the command to create a package, which is King create package, name of the package, which is my robot manager, and dependencies here at the end. ROS CPP and nav messages as dependencies. All right? Let's run it. Okay. So now, if you run an ls command, you are going to see my robot manager package here. Also, you are going to see it here in the IDE. Okay? My robot manager. Yeah, it creates some folders and files by default, as you can see. So by default, it creates this include folder, SRC folder, and CMake lists and package XML files. Okay, very important. All right. Let's keep going. So we are going to create our header file. Okay, where? Well, you're going to create it here, inside the include folder and inside the My Robot Manager. Yeah? So inside include and inside My Robot Manager. Here you're going to create a new file named robotmanager.h. Okay? And then here we are going to copy and paste the code that you have here in the notebook in robotmanager.h. All right? Then what are we doing here? Here we are defining the class. Yeah, we are defining all the data members and member functions of our class. So we have some includes. We are including ROS, odometry message, etc. We define our class, which is robot manager. And then, as public, I am defining here a constructor. Okay, this is a parameterized constructor of my class. In this case, this constructor is expecting to receive a node handle object. Okay? And also, as public, I am defining a member function, odom callback. Okay? As you can see, I am just defining them, right? So this is the difference. If you look here to the previous codes that you were creating, here you are defining and you are implementing the constructor, right? Or here, you are defining it and you are implementing it. Implementing it means implementing what the constructor is going to do, right? But here we are not. Here we are only defining it. But we have not implemented yet what we are going to do inside this constructor. We only define it. We say, hey, this class has a public constructor, which is a parameterized constructor, which should receive a node handle object. And it also has a public member function named odom callback. And also, my class has here some private data members. In this case, the data members are current X position, current Y position, odometry topic as a string, and odom subscriber, which is a subscriber object. Okay? So here I am already defining some private data members. So all these data members are not going to be accessible for anybody outside the class. Yeah? they are going to be only accessible inside the class. Yeah? Okay, so this is our header file. This is known as the header file, where you define your class. Now, we have to implement our class. This is done in the source file. Then the source file, we are going to put it where? We are going to put it here, inside the src folder, right? Inside the src folder, I'm going to put the CPP file, which is robotmanager.cpp. Okay? And again, I'm going to copy and paste the code here from the notebook. Okay? Now, what am I doing here? Basically, I'm doing two things. I'm implementing my constructor, right? So here I am implementing my constructor. Yeah? The constructor that I defined here I am implementing it. So what is the constructor of my class going to do? It's going to create a subscriber. Yes? And also, I am implementing this ODOM callback member function. So this member function, what's going to do is to receive an odometry message and store this value into the current X and current Y position data members. Yeah? And I can modify these data members because here I am inside the class. Okay? This is inside the class. Yeah? Are you following more or less? I know there are some complicated things here, but yeah, so unfortunately we have the time that we have. In fact, we have already reached the time, but at least I would like you to get the general idea, okay? To grasp some things here, and then later you can review the notebook and review everything more slowly. Yeah, remember that you are going to get this rosject forever, so you can open it whenever you want and review it, and review the class also, which we are going to upload to YouTube, etc. Okay? Yeah. So important. We divide our class into files: the header file, where we have the definitions, and the source file, where we have the implementations. Yeah? Then, finally, we are going to also add our main code. Okay? The main code. Oops. Then the main code that we have here, we are going to also place it in the src folder. Yeah? So this one we are going to name it robotmanager_node.cpp. Yeah? It's like this, right? Robotmanager_node.cpp. Okay. All right. So this is the main code, which is already outside the class. Okay? This is outside the class. Now here in the main function, I am importing the header file of my class so that I can use it. Yeah? Whenever you import, you are going to import the header file. Yeah, not the CPP file. You are going to always import the header file. Yeah, so you import the header file of the class. Then in the main function, you initiate a ROS node. You create a node handle object. And then you create an object of the class. See? So you are creating here an object of the class, and here you are calling the parameterized constructor. Yeah, this is the parameterized constructor that you have defined here. And as you can see, this parameterized constructor, it requires another handle, right? So I am calling the parameterized constructor passing this node handle here, right? And then this parameterized constructor, what it's going to do is to initialize here a ROS subscriber for the odometry topic. Okay? And then finally, we just call the spin function, which is it's going to keep the program alive until somebody manually terminates it. Okay? Yes, no, makes sense. You are completely lost. You are about to faint. Okay. I am not seeing any comments, so I'm not sure for what to think. But okay, we are almost finishing, okay? Only part remaining is the CMake file, okay? So now I have created the main structure, which is, I have created the header file of my class, the source file of my class, and I have created the main node, which uses my class, yeah? So now I need to compile all this, right? I need to build it. So in the previous examples, we were building using this clang tool. Remember that we were building using this clang? Okay, so in ROS, you have a more sophisticated build system, which is managed through this CMake_list.txt file, okay? Then basically this file contains all the rules for compilation. Yeah, so we are going to be adding things step by step and try to understand what we are doing, right? So first of all, we are going to define, we are going to to implement here this catkin package function. Yeah, so if you scroll down here a little bit, you are going to see this catkin package function, okay? You can also hit here in the file Control F, which is going to open this search bar, and then here you can search for catkin package, yeah? In like this, yeah? And you are going to find this function, okay? So here, basically, we are going to uncomment all this, yeah? So we are going to uncomment the include dirs, the libraries, and the catkin depends, yeah, as you can see from here. If you want to make it simpler, also you can just copy all these lines here from the notebook and paste them directly to here, okay? It's the same. Yeah? So basically, here, note that we are including the directory include project name. Project name, if you look up here, is my robot manager. Yeah? So here, I am including the directory include my robot manager, which is this directory, where inside the directory I have my header file. Okay? This is a little bit complicated. CMake list files are pretty complicated to understand, okay? So please don't panic, yeah, because there are many lines here, many things. Don't worry, just try to get the main ideas, and then later, if you are interested in, you can review a little bit more in detail this, okay? So Okay. So now we are going to uncomment also the include directories function, which we have down here. Yeah, include directories. So as you can see here, we need to also uncomment the include here. Yeah, as you can see, this is specify additional locations for header files. Okay. So I have header files in the include folder. This is what I am saying here, basically. Okay, then very important, add library function. Okay, so I have it down here. Declare a C++ library. So I'm going to uncomment all this. Yeah, very important, add library function. Then here, I am going to add a library, which I'm going to name project name plus underscore lib. I am going to append an underscore lib at the end. Yeah, so this project name, remember, is my robot manager. So this is going to be my robot manager underscore lib. This is going to be the name of my library, the library that is going to contain my class. Okay? And I'm going to create this library from what code? From the code that I have in Robot Manager CPP, in SRC Robot Manager CPP, right? So the code is inside the SRC folder, and it's Robot Manager CPP. So let me remove the project name here from the middle. Yeah, SRC Robot Manager CPP. So from this source file, well, actually it's not my, yeah, it's Robot Manager. It's not my Robot Manager, right? It's the name of the file is robotmanager.cpp. Yeah, so from this code, I'm going to generate a library named my robot manager underscore lib. Okay, important. Now we are going to generate an executable, which is the one that we are going to actually run. Okay, so for this, let me copy these two lines here, and I'm going to paste them down here, for instance. Okay, so I am generating an executable named like this, robot manager node, from the robot manager node CPP file and robot manager CPP file. And as I am going to link my library, my robot manager lib, to my executable node. Okay? Yeah, I know. This is this is a lot, but yeah. So CMake list files are complex, and if you are not used to it, it's a little bit hard to understand. Okay? But anyways, let's try to compile all this and see what happens. So in order to compile, also important, we need to go to the source of our workspace, Catkin workspace. Then to compile in ROS, we use the catkin make command. Yeah, this is going to start all the compilation and build processes. It's going to generate the library, generate the executable, link the library to the executable, all this kind of stuff. Yeah, so here, as you can see, it's building the library. Yeah? If you read here at the messages, here it's building the library. My robot manager lib. Here it's linking the library. Yeah? Here it's building the robot manager node. And generating the executable. And finally, it's linking the executable to the library. Yeah, 100%, and it has finished. So now I can source, and now I can run my node with the ROS run command. ROS run, my robot manager, which is the name of the ROS package, and robot manager node, which is the name of the executable. Yeah, it's the name of the executable. robot manager node. Okay, so if I run this, then it's going to work, everything is going to work out, and we start getting the position in X and Y of the robot. Yeah, so this is getting the live position of the robot in the simulation. Okay, for instance, if I start moving robot 1, I'm going to see these values updated. So ROS topic pop, robot 1 command vel, geometry messages twist, and then, for instance, I'm going to start moving here the robot backwards. Yeah, we should see the robot here start moving backwards. You see it there. And then here in my class, you are going to see that the values of the position X start moving backwards. Okay? And yeah, so basically that's it. Okay? So we are already 15 minutes past the time. Let me stop the robot, by the way, here by publishing a 0 velocity. There we go. Yeah, the topic is this one. I'm going to share it here. Robot 1 command bell. This is the topic that you can use to move this robot. Okay? So yeah, basically that's it. All right? Then just a very quick summary, okay, so that you get so many ideas. Whenever you use classes in ROS, the general structure is going to be like this, okay? So you are going to have a header file, which is .h, with the definition of your class, and a source file, CPP file, with the implementation of your class. Yeah, and then you are going to generate a library from your class. Yeah, and then from another node, you are going to be using your class. Okay? So this is going to be the general structure. Yeah? So here you can see it also in the CMake list that you declare the C++ library, and then you generate your executable and you link the library to the executable. Okay? So yeah, I know some of these things are a little bit complicated, especially if you are not familiar with them. But yeah, so at least you get the initial idea, all right? And then you have now these foundations, these bases, so that you can keep investigating on your own. You can keep working on the rosject, review it whenever you want, and get deeper into it, okay? So just before finishing, let me link you here to the C++ for Robotics course, which is the free one. And also, okay, we have just published this course, okay, which is the advanced version of the course. Let me share with you the link here. Yeah, which is let's say it's the continuation of this course, where you are going to go for more advanced topics and go much more into detail of many things, like C++ classes. You are going to get into much more details, and many other things. Okay. So yeah, let me already finish it here. So let me say thanks for all of you. I hope that you have liked this class. I hope that you've learned something, at least, that you can take something from this hour and 15 minutes that we've been here together. So yeah, thanks to all of you. Let me do one last thing, actually, before closing, which is to share with all of you the form rate, because I'm particularly interested in today's feedback, since we have been doing something which is a little bit more complicated. I want to see what's your reaction. So yeah, here in a few moments, it's going to appear. I'm going to activate it right now, the rate form, okay? So you can just rate this presentation if you liked it more or you liked it less, whatever you want, okay? And yeah, so that's all. Thanks a lot. I will see you as always again next Tuesday in the next open class. And until then, take care and keep pushing your ROS learning. Bye bye.